There's a very simple step-by-step process that you can follow to solve pretty much any separable differential equation you're going to run into. As long as you keep this process in mind as you're solving a separable differential equation problem, you should be able to avoid most problems that will kind of steer you to the wrong answer and help you get the right answer a lot faster and with a lot less frustration pretty much every time. If that sounds good to you, be sure to stick around to the end of the video because I'm going to be showing you this entire process step by step so that you can have your own blueprint that you can kind of keep by your side as you're working through a separable differential equation. So let's go ahead and jump into that process and I'll show you what I'm talking about. The first thing you want to think about when you're looking at a separable differential equation example, typically the problem is not going to say solve the separable differential equation. They're not necessarily going to tell you, and of course this does sometimes happen. I like to say that this never happens, but sometimes they will tell you this is a separable differential equation, solve it, but not always. So the first question you need to ask is this a separable differential equation? Typically, a differential equation problem, they're just going to give you a differential equation, which really is just any equation that relates x, y, and dy dx. Now, of course, the letters could change. It could be something like xt and dx dt, right? It doesn't really matter what the letters are. The point is it's going to be two variables and then the derivative of one of your variables with respect to the other variable. So you're kind of going to get this situation where you have these three different letters. One's a function, one's a variable, and then your d something, dy dx, or dx dt is just going to represent the derivative of your function with respect to your variable. So an equation that contains those three things is considered a differential equation. So what makes a differential equation a separable differential equation? Well, it's pretty simple. Basically, it needs to be in one of two forms, either as it's given, or you need to be able to algebraically kind of manipulate your differential equation to get it into one of these two forms. So let's say that we are dealing with a differential equation using x, y, and dy dx. There's two forms that we could have our differential equation be. One is that we would essentially be able to separate out our equation. It depends on if you have x's on the left side of your equation, y's on the right side, or if they're all mixed together or what. But what you should be able to do is either divide or multiply anything from the left-hand side of your equation to the right-hand side, or vice versa, in order to get it into one of these two forms. And the forms are, you would either have dy dx equals some function of x times some function of y, or the other form that it could be in is you would be able to get it into the form dy dx equals some function of x over some function of y. So like I said, it may not be given in this form. We may have some sort of a situation where maybe we have x's and y's all mixed together on one side of our equation. So maybe we have dy dx equals something with x's and y's in it over here, but maybe we can factor this out to get us into one of these two forms. Or maybe we have some y's over here and some dy dx's, and we can kind of move things back and forth between the left and the right of the equation to kind of get it into one of these forms. Okay, so the point is we need to be able to manipulate whatever equation we're given to get it into one of these two forms. Once we know that we can do that, or if the equation is given already in one of these two forms, then we know that we have a separable differential equation. So from there, the first step, like I said, is you would want to get it into one of these two forms. Okay, once you've gotten it into one of these two forms, the next step is to separate your x terms on one side of your equation and your y terms over to the other side of the equation. So depending on which of these two forms you got to, the way that will work will be a little bit different. If you have form number one, your next step at this point is going to be simply to divide both sides of your equation by this g of y. So you divide both sides by g of y, or in other words, multiply by 1 over g of y. That probably would be the better way to write this. And doing that will cancel your g of y over on the right side of the equation. And then what you can also do is multiply both sides of your equation by dx. So I know that probably seems kind of weird. Dx isn't necessarily typically a term that you would like multiply over to the equation like that. But with differential equations, especially separable differential equations, you can think of the dx and the dy as their own terms, basically. So basically that'll cancel the dx on the left side of our equation and move it over to the right. So essentially, once we do that, all we would end up with is moving all of our y's from the right side of our equation over to the left, moving our x from the left side of the equation over to the right, and we would just end up with g of y times dy equals f of x times dx. So this is why it's called a separable differential equation, because we can separate the x's and the y's. We can separate the letters that represent our variable from the letter that represents our function. In this case, it's x and y, but like I said before, it could be x and t or whatever else. The actual letters don't really matter, but the idea is that we can separate them, okay? If we had it in this form, similarly, we would be able to multiply by g of y to move that over to the left side, multiply by dx to be able to move that over to the right side. Of course, whatever you do to one side, you do to the other side as well. So we would multiply our gy to the left side, giving us g of y dy equals, oh, wait a second. I did this first one wrong. I'm sorry. This should be, remember we wanted to multiply by 1 over g of y in this first example here. So 1 over g of y would be multiplied to the left side of the equation. In the first example, we have 1 over g of y, and then in the second one, we have g of y times dy. And then similarly, multiply the dx over, just leaves us with f of x dx. So basically, we either get it to 1 over g of y dy or g of y dy equals f of x dx. Okay. So then from there, once we have separated out our variables, regardless of which of these two forms you have, the next step is going to be the same. We basically would just add an integral onto both sides of our equation, which means that we're going to be left with either 1 over g of y dy equals the integral of f of x dx. And if we had this one down here instead, we'd have the integral of g of y dy equals the integral of f of x dx. Okay, so once you've thrown on your integral sign, since you've done it to one side of the equation, or since you've done the same thing to both sides of the equation, we haven't changed the fact that these two things are equal. Then from here, you would just integrate. So then your next step is to integrate both sides. And then once you've actually taken the integral of both sides of your equation, then you would isolate y. Or in other words, solve for y. So then after this point, you should just have y equals some function of x. And then if you were also given an initial condition to deal with, you would solve for your unknown constant that was introduced in this step right here. So when you integrate both sides of your equation, you should have a plus c, that you would introduce through integrating. And then if you have an initial condition, you would solve for your constant. Usually C, but could be really whatever letter you decide you like. So yeah, that's it. There's basically just going to be these 6 or 5 steps, depending on if you have an initial condition or not. If you do not have an initial condition, you would be done after this step, and you would have a plus C somewhere in your answer. If you were given an initial condition, you have to solve for that plus c and figure out what it actually is. The steps in the process that we just talked about in this video should be super helpful for you, but without actually seeing examples of how to apply it to a problem, it's going to be tough for you to really get it down. So if you're one of the 98% of people who's watching this video who's not subscribed to my channel, just go click right over there, subscribe, hit that bell icon, and turn on all notifications, because my next couple videos are going to be showing you examples of how to actually apply the steps we just went over, so you can ace this topic on your next test. How's that sound?